Episode 3, What if you fell onto Jupiter? What if you fell onto Jupiter? First, we have to fix one word in that question, onto, because Jupiter is not like Earth with a hidden giant floor under the clouds. It is not a rocky planet wearing a thick atmosphere. It is mostly hydrogen and helium, wrapped so deeply around itself that the line between sky and planet becomes strange. So if you fell toward Jupiter, you would not land. You would enter, and that is much worse. Let us imagine a magical version of you in an indestructible observation suit, because a normal human body would not survive this. You start far above the cloud tops. At first, Jupiter looks beautiful. Cream, rust, white, and brown bands wrap around the planet like painted storms. The Great Red Spot is not a freckle. It is a storm larger than Earth on a planet so huge that the scale breaks your instincts. You're not falling toward a place. You're falling toward a weather system the size of a world. As you get closer, gravity becomes the first problem. At Jupiter's cloud tops, gravity is about 2.5 times Earth's gravity, but the bigger danger is speed. Jupiter is massive, so as you fall in, it pulls you faster and faster. Without a rocket slowing you down, you would hit the upper atmosphere at terrifying speed. The air would not feel like air, it would feel like a wall made of gas. At those speeds, the gas in front of you gets squeezed and heated, not warmed, blasted. NASA's Galileo probe entered Jupiter in 1995 with a heat shield, and even that machine experienced brutal heating. A person would never get to enjoy the view. But our magical suit keeps watching. The first clouds you meet are not fluffy water clouds like Earth's high. In Jupiter's atmosphere, clouds can be ammonia ice crystals floating in freezing hydrogen and helium. You fall through pale decks, darker belts, and winds screaming sideways at hundreds of kilometers per hour. There is no quiet descent. Jupiter's atmosphere is moving, shearing, rotating, and folding over itself. On Earth, weather happens in a thin skin around a solid planet. On Jupiter, weather is the planet's face. Soon, the pressure begins to climb. Pressure is easy to underestimate because we live inside it every day. But pressure is not just weight from above. It pushes from every direction. It squeezes. At 10 times Earth's sea level pressure, you're already beyond any normal human environment. The Galileo probe kept transmitting for less than an hour after entry. By the time its signal ended, the pressure was already dozens of times stronger than Earth's sea level air pressure. That is the strange thing about Jupiter. You can fall a tiny fraction of the planet's radius and already be somewhere no longer Earth-like. And you're still nowhere near a surface, because there is no surface. As you go deeper, the hydrogen around you becomes denser and hotter. The sky stops behaving like sky. It becomes more like a crushing ocean made of gas turning into fluid. Go deeper still, and the hydrogen changes again. Under enormous pressure, hydrogen can become metallic hydrogen, a strange state that conducts electricity. This helps explain Jupiter's powerful magnetic field. But you would not pass a neat boundary with a sign that says, "Welcome to metallic hydrogen." Nature rarely labels the weird parts. It would be a gradual transformation from gas to dense fluid to stranger matter. Meanwhile, the temperature keeps rising. Freezing cold becomes oven hot becomes molten metal hot, then hotter than almost anything your everyday brain has a category for. At the same time, the pressure becomes millions of times stronger than Earth's atmosphere. Any normal spacecraft would be long gone as a useful object. So what would falling onto Jupiter feel like? It would not feel like hitting ground. It would feel like being erased by a planet that never offers you a floor. First, radiation and speed threaten you from above. Then, entry heating turns the fall into fire. Then winds throw you sideways. Then pressure and heat destroy anything not protected by impossible technology. And still, the fall continues. That is the most unsettling part. On Earth, falling has an ending. You hit water, you hit rock, you hit something. On Jupiter, the ending is not a surface. The ending is a gradual loss of meaning for the word falling. You sink into denser material until pressure and heat make the idea of a traveler meaningless. If Jupiter has a core, it is probably not a crisp little stone ball waiting at the center. Juno measurements suggest the deep interior may be fuzzy, with heavier materials mixed into hydrogen. Jupiter is not a planet you stand on. It is a planet you disappear into. And that teaches us something important. The solar system is not just a collection of bigger and smaller Earths. Some worlds are giant gravitational machines, holding storms, fluids, magnetic fields, and strange matter under their own weight. So if you fell onto Jupiter, the short answer is you would never land. The longer answer is you would become a very temporary visitor inside a planet-sized atmosphere. Beautiful at the top, violent below, no ground, no rescue, just deeper.